Oh, is that, there's little buttons on each one? Oh man, you should do that for all of them. It'd probably help you out a lot starting to see up front.
That one.
This one? Yeah, you know, trust me, if I could smash this down, I would. Usually I try to teach all my classes off the laptop, but there's not a connector here that extends to the projector. Usually I need like an HDMI cord. And this looks like it's from the early 2000s here, so not quite there. Yikes. Nope. So I got to use this like clunky thing, unfortunately. Okay, so did you guys have a chance to keep up on some of the announcements I was able to try to send out to you guys the last week or two? Yeah, I tried to give you guys some citations, some stuff to read and keep in mind and think about. And let's see here. Did anybody try the averaging process for the pictures to reflect that concept that we talked about for averaging ERPs versus oscillations? Yeah?
We tried it, couldn't figure it out.
Yeah, me too.
Okay, what did you do?
Huh?
How did you do it?
You know, it was so long ago, I don't recall. It was before the semester started. I was trying to
layer the pictures and then change, like, that's what it said to do. That's how you average them in like Photoshop.
Yeah.
And it looked really funny. It looked really weird. It averaged, I think it did.
Maybe that's what it is.
You're like half smiling with them.
Oh god. Well, did you try the ones without me in it? There's a whole other section that you could.
I tried the first set.
Yeah, because there's like the better set without me.
But I just tried the first set. So I thought it was pretty.
Yeah. Yeah. So I mean, I tried Googling how to do it in Photoshop a while back, and I'm not very good with Photoshop. I know Illustrator fairly well, but Photoshop just hasn't been something I've had an opportunity to learn yet. So they started talking about layering and doing all this stuff, and I tried poking around, and I had to like wail my hands and scream for help, and it wasn't pretty. So I thought maybe some of you guys might be more technologically savvy and smarter than I on that. So
I sent him along to a buddy of mine who does photography for like wakeboarders and stuff.
Oh, really?
Like that, so maybe he could do something.
Oh, cool. I thought you were gonna say you sent it along to a buddy of yours who does like horrible like internet memes to like make fun of me and do some
He might.
horrible photoshopping of who knows what.
Either way at this point.
Yeah.
Yeah.
He still hasn't said anything back.
Okay. Yeah, I mean, if anybody sorts it out and figures it out, it'd be kind of cool. And we can actually see that principle in sort of real life evident from the concept that we talk about, and certainly Scott McKee talks about in the 2004 paper. Did you guys have a chance to take a look at that one at all? No? So I think I referred to it in the last announcement that I made. And anywho, Scott McKee has a paper. I think it's on our e-learning site. Is 2004, and that's where that concept and that analogy comes from of averaging pictures at the seashore as a conceptual analog to averaging ERPs, as opposed to being able to measure the waves of an oscillation. So I think it'd be cool to be able to actually use a real example of that either in presentations or in class that corresponds to that actual idea, because I think it's a really useful way to help teach people the value of oscillations and the analysis of oscillations, because it really helps to give a lot more insight into what actually happened, be it in the experiments or on the vacation to the beach. So if you can figure it out, that'd be pretty cool. I'll even offer extra credit for it. So, although professional wakeboarding photographers don't count for extra credit, just fair warning.
Yeah, just resources, right?
Yeah. Yeah.
Did you said your friend did it, right?
My friend?
Like, did you say
I don't have friends.
No,
Don't you know me? Everybody who thinks I'm a big fat jerk. I have no friends.
You said like somebody, I guess, did this, right?
I said that the guy wrote about it in the paper, I think. Maybe. I mean, I might have.
I'm telling you, like, I thought it'd be really cool to do.
Yeah.
Except you don't talk like that.
No, I do talk like that sometimes.
Okay, well, never mind then.
No, I don't remember. To be honest, I don't remember. I mean, I can go back and check out the classes content, but who wants to sit through that for another 2 hours and 45 minutes?
Yeah.
I think I saw online because I was trying to look it up as well.
Yeah.
It said there's a code you can put into MATLAB to do it.
Yeah.
But I was like, I'm already having trouble with this.
No, that's the best thing about it. You don't have to go
Yeah, because then you would have to do it manually in Photoshop. So.
Yeah, you have to adjust each layer to fit perfectly manually.
Yeah, if there's a code, right? That's like one of the like hallmark points I want to like leave you guys with as you graduate from class is the beautiful utility and elegance of code. Sometimes code is really ugly and not beautiful and elegant at all. But conceptually, if you can take a line of code, copy it from the Google Webs, and paste it into MATLAB and press enter, and it does what you want, how awesome is that? That could save you hours of manual resetting the layers and all that kind of jazz. Like that's like the essence of coding and why it's fantastic and really efficient in a research context. So yeah, I mean, hey, if you can find
I'll try it out and see what happens.
Hey, the worst that can happen is you get all these goofy red freak out messages that we're used to seeing anyways, right?
So just make sure to do it at school right now. In one of those computers at school.
Well, I don't know if it would matter which computer you use.
Well, because his MATLAB is already set in a certain way. So
Yeah, but I don't know that if you get an error message with the code, I don't know that it would necessarily mess with it in a fundamental way. I mean, you might want to read the code first and see if there's sections in there that say save or anything like that. If you're going to save a fundamental, I don't think it's going to actually save like one of the functions of MATLAB differently. But that's a good point to note, just more broadly, if you get interested in computer programming in MATLAB code or any type of code. Yeah, obviously, you do want to read what you're doing before you do it, just to know, to try to get an idea of what's happening. That's kind of good practice for anything, right? You always check the quality of the turf before you step out onto the field. Useful things to know in computer programming. So yeah, if you can sort it out and get a cool picture out of it, that'd be cool. Anybody still think that they might embark on the extra credit idea for making some screencasts? Okay. Well, maybe what you guys can do, or what we can try to do, is set up maybe like a forum or something on e-learning, so that we can have different people working on different screencast topics for different things. That way we don't get everybody making a screencast about how to set a path. You know what I mean? Ariel, do you think that that's possible to make like a little forum or something that's interactive on there, where people can just, it can even be like a Google document on Excel or something like that is shared with everyone, where they just sign up, they just put their name down and just say what topic they want to do, and then if you guys happen to see that you have, or that you're doing the same thing as someone else, I'll basically at this point, at first pass, I'll sort of take the assumption of adulthood here and assume that you guys can sort it out on your own. You know, so if both you guys see that you're doing the same topic, I'll just assume you can communicate and sort it out. If you need me to help, then appeal to me and ask, or Ariel, or we're happy to help sort out who can do what. But at first pass, I want to give you guys the respect of being able to do it on your own, rather than bringing more cooks to the kitchen. That sound fair? Yeah. Okay. Cool. So yeah, check that stuff out. So did you guys said you had a chance to check out some of the readings I suggested? What'd you think of them?
I mean, I read your paper.
I'm sorry to hear that.
No, it's good.
Anybody else read something that was actually interesting?
You said Cohen part 3.
Oh yeah.
Like 6 chapters.
Yeah, that's a lot.
Yeah. Well, you notice that's spread out over a couple. You know, I've said it now for a couple weeks. I'm trying to be gentle on.
But I just picked up all that, the neural oscillations, but honestly, I don't think I get it quite yet.
Okay. Well, this is a good chance to talk about it and chat about things that we might be able to clarify.
Well, because I thought we just needed to be familiar with it. So.
Anything jump off at the top of your head of something that was like an area where the dots were quite connecting?
I remember there were some limitations.
Okay, that's cool. Anybody else was struck by anything that they read they thought was cool or interesting or useful? So it's mostly a lot of the oscillation related literature, right? So was there something about it that you wanted to review that I can help with? Was it interesting? It's kind of dry.
Yeah.
Yeah.
It's very-
Yeah. So it's just different ways of looking at the data. And so kind of what I alluded to last class is try to structure the remaining sections of the class to have some other people come in and talk about it in different ways too. So Dr. De La Rosa will be here, I believe, next week, and then after that we'll talk about some graph theory. I think there's an even chapter in the Cohen book that talks about graph theory. I'm not sure that we've gotten there quite yet, but it's a really interesting way of thinking about things. So that stuff's on the horizon. Read it if you'd like. Keep notes of questions and stuff that doesn't make sense or whatever, and email me or bring it to class. We can talk about it, because I do want to give you guys the opportunity to try some analyses with it. And if you note, the e-learning site for the class has folders for different videos from EEG lab tutorials, and part of them are from a class that Scott McKee's lab runs on how to use EEG lab, and particularly how to use it to do oscillation analyses. And so they're really good resources because they actually walk you through certain step-by-steps and explain also some of the conceptual backings of that too. So you can find that a lot of that material either on the e-learning site or also on the EEG Lab website. If you go to the wiki, remember where we downloaded it from? If you go there, there's probably 100 and some odd links on that wiki, but some of them link to the course or to tutorials or to videos. And you go through there, and it's actually really good. I think it was actually the class I attended a couple years ago when they video streamed it or something. So I remember certain, reasonable amounts of it, and it was very good. So if you guys find that stuff interesting, do that. So I said to be familiar with those things, and let's see here. So you said that you had the misfortune of reading my paper?
Yes.
I'm sorry to hear that again. And one of the reasons why I suggested it is to broaden our understanding of ways that we can analyze the data with EEG Lab, and particularly to be able to capture measures of non-conscious memory. So if you guys would like, I'd be happy to share with you some of the new procedures that we're developing in order to do that with this type of data. One, because of course we all do like to talk about our own work, so it's always a joy for me because it's like my baby, and our children can do no wrong. But goofing around aside, it is an opportunity for me to give you an area of expertise that you can actually get your money's worth from. So I can share that if you'd like. One of the reasons why I wanted to treat you guys to coffee and snacks wasn't just in compensation for suffering through my paper. I'm actually really excited to celebrate today because I found out this morning I got a paper accepted for publication, so I'm pretty pumped. Thank you. So it's actually really cool. It actually kind of is about implicit memory in some ways. So you guys have an idea of ever hear what fluency is?
What?
Fluency. So basically, we can think about some frameworks. We'll talk a little bit about, I guess, cognitive psychology here. So you guys remember all our standard memory paradigms. I think we might have talked about it in this class, but also probably behavioral neuroscience, right? You basically have these different framework sections that may say memory goes, so you can encode, consolidate, and then we have retrieval. Okay, and then remember, of course, that's it within a broader framework of short-term memory and going to long-term memory, and of course there's kind of like this sensory memory beforehand. Kind of what we've been talking about here is all long-term memory, so this is all kind of like part of this section here, right? So for long-term memory, you've got to encode, it becomes consolidated, and hopefully you can retrieve it sometimes. Of course, it doesn't always work because we forget things on occasion, so sometimes we don't have the ability to retrieve it, but oftentimes we can get it later, which means that it was not a failure to encode the information. It got in there, we just reached down, tried to pull it up, and it slipped out of our hands. We had a retrieval error. So all that is basically, well, everything we talk about in this class is long-term memory. But of course, there's other types of memory, short-term memory or working memory. And then, do you guys remember this? Is this like kicking up some dust from like, these are like really famous pictures in introductory textbooks and stuff like that. And then there's like sensory memory. And so fluency is basically the idea of, it's kind of on this early level of sensory memory, way before all this other stuff. And it's just kind of that sense of how fluent something seems to you. I hate to have like a circular definition, right? Those are bad. You never want to do that and say, well, what fluency is that sense of fluency, right? That's always kind of lame. But basically, conceptually, like a cognitive psychology level, the idea is that as things are repeated in life, right, you come across things more and more, the ease of processing that information is what fluency refers to and represents.
So it's like expertise.
No, expertise, I would actually say, it's probably related to expertise, but it's not expertise per se. I think I would anecdotally think of expertise as more like a conscious process, something that's top down and deliberative. So by top down, I mean like our higher cognitive conscious resources working in a hierarchically controlling fashion, as opposed to bottom up sensory stimuli that's sort of outside of the awareness of consciousness. Fluency is more on that bottom up level. So it's basically as things are repeated more and more, they come to you a little bit more fluently because there's an ease of processing at the sensory level, right? So when you first see, the first time I opened up MATLAB for you guys, it was like, what the heck is this, right? And that first crazy red error message you got, it's like, nails on a chalkboard, right? But of course, as you gain your mastery with working with MATLAB and you get used to it, right, you get a little bit more fluent in it, like a language. And the more and more it repeats, right, that ease of processing, it just kind of becomes a little bit more seamless at a very, very basic sensory level. Yes, Val?
So it would be like the transition from conscious to unconscious processing?
Good question, but it's actually not what I would say in this particular domain. It's not the transition between the two. It's just representing that first stage of early sensory processing when something seems a little bit more fluent. That's all. And so we used ERPs to categorize basically how fluent certain pictures of items were. And what was really cool about it, any guys business majors are interested in marketing or any of that kind of jazz? No? What's that?
I can't imagine why they take this class.
Well, it could be a gen ed, could be a dual major, could be, they heard it was the best class in the campus. But, lots of reasons. I can imagine lots of reasons why they might take it. So what was really cool about this is, and this should be one reason why they should have thought to take the class, is so marketing is basically or so is advertising. Anything in business, what you're trying to accomplish is modifying human behavior. How and why? How and why is that the case? Yeah, you want people to change their behavior from not buying your junk to buying your junk, right? Right? Think of like famous salespeople, like they're really good, right? Like car salesman, Donald Trump, right? Sells hotel rooms or casinos or whatnot, right? Really, really good at making sales pitches. You want to take somebody who doesn't want your stuff and give them, all right, yeah, okay, I'll buy it. Here's some money. Take it from me, right? You want to sell ice to an Eskimo, right? It's very good. You want to change their behavior, which is actually what the study psychology is. And of course, related stuff in neuroscience kind of taps into that. So there is a relationship there. And what we did was we took pictures of items, like products essentially, cereal boxes, squirt guns, whatever. And we basically found, and we asked people we presented it really, really fast, like 50 milliseconds when they did encoding. And then later we recorded ERPs at retrieval. And what we ended up finding was, or what we did at retrieval is we asked them if they remembered it, yes or no, blah, blah, blah. But then we also asked them, do you like this item? You just gave them like a liking rating, you know? And this is something that cuts to the heart of what every advertiser or marketer has known for a while, because it's a famous effect in the social psychology literature. It's called the mirror exposure effect. Now, I'm not talking about Snow White's mirror, mirror on the wall. I'm talking about mirror, M-E-R-E. Mirror exposure means by just merely been exposed to this thing during encoding, you know what it means at retrieval? For old items, even if they don't remember having seen it before, people reliably rate it as liking it more than items that they didn't see before. Which is why it's good to invest in billboards and advertising and all that kind of stuff. And so we basically found ERP correlates, figuring out why that liking effect, that mirror exposure effect is happening, related to basic fluency in this bottom-up processing. So anyways, little tangents as to the reasons of your coffee and bagels. Yeah.
So there's I wanted to ask, there's I believe in psychology or something, they've said that if you do mazes all day long, you'll be better at doing mazes in the future. Is that more fluency thing or an expertise thing?
Good question. If you do mazes all day long, you're more likely to do better at mazes in the future. Yeah, I mean, practice does make perfect.
But I mean, not the same ones. It's like different mazes every day.
Yeah. I mean, so the question is that fluency or expertise? It's probably a little bit of both. You probably gain some expertise by knowing gaining experience with experience of strategies that are successful for navigating mazes, and knowing some of the pitfalls and traps to avoid, getting lured into. And one of the reasons you might be able to do that is by relying on better fluency that might come about. So that's where I say I draw this like semantic distinction between, is it fluency? I don't know that I would say it is. I would say that probably is that fluency, though, may be very much contributing to that effect. Is the distinction clear that I'm trying to make?
Sort of, yeah.
Yeah, and the reason I try to be really clear about that is because I want you guys to be able to be clear about making these distinctions later in life when people expect you to know what you're talking about in neuroscience or psychology or data analysis and things like that. Because I don't want you guys to be embarrassed by other people who are like, oh, well, that doesn't mean that and this doesn't mean this. I want to try to like make sure that you guys don't fall into any traps at like really snooty cocktail parties where there's going to be really arrogant, condescending people, their little pinkies in the air, saying, well, that doesn't quite mean that. I want to help you guys avoid those traps. Because that stinks, because then you got to tell them that they're a big flaming jerk and nobody likes them, and to quit being so arrogant and all that.
And you never came back to the cocktail party again.
Which is probably a good thing. But nevertheless, I just want to make sure that we can leave here with my job being done, being that I set you up for the most accurate ways to characterize and understand things. So, anywho, so that's that. Help yourself to, go back, get seconds, get thirds, knock yourselves out. What I wanted to do today was answer any questions if people had about the project that was due today, the second lab report. Give you an opportunity to talk about that if you want. Hopefully, I haven't checked my email or anything like that, but I'm hoping that people have had a chance to forward that and do that. So hopefully you guys did basically added a second experiment to that, our ongoing building lab report, using new hypotheses of different contrasts, different latencies, different hypotheses there, and you could have, and ideally suggested, move to a whole new data set for that. So like, let's say the face memory ERPs, or something of that accord, and added in a discussion section. And I think an abstract, if we hadn't done that before, and basically really starting to pull the whole report together. Make sure we have references and APA format, all that kind of good jazz. So, question?
The final lab report, given the semester, now is that going to be we're gonna add a third experience to that.
Yeah.
So how exactly do you want, I'm a little confused when like it all comes together. I know that you want us to refer to it as experiment 1 and experiment 2, experiment
Yeah.
3, but at the beginning, like in the abstract or in the method section, should we kind of like explain each one of them? Because I feel like that's gonna be really long.
Yeah. It will probably end up being sort of long, but I don't want to read a massive dissertation either. So what's good for you is good for me, actually, in this case, right? So the longer it is for you, that's kind of a pain for you, and multiply that by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13 for me. So my goal is to keep it as short as possible. And maybe more to the point of your question, kind of the idea is, in your introduction, you might introduce, first of all, you're going to start very broadly, right? Like we're interested in memory, so we're studying these types of things. And then you might break it down paragraph by paragraph into a little bit greater specificity, right? For the types of questions or issues that you're interested in, that each of these different respective experiments are going to be suited for addressing in their own specific ways, right? So, and this is just an example off the cuff, but you could be like, we're interested in memory, so we did experiment 1 that looked at activity during encoding. Then we also wanted to study how activity was related to memory consolidation, so we did experiment 2 that manipulated aspects of consolidation. We did experiment 3 that looked at memory retrieval. That's not actually true for our study. I just want to be clear about that, so that doesn't get accidentally transcribed. But it's a way to frame things of the specific nature of what was done within the broader question and goal. And so that can be sort of, it's as simple as like a paragraph for each of the goals or whatever. And then what you can do 2 different options for, say, the result, or the results are, you're going to have experiment 1, describe those results, experiment 2, describe those results, experiment 3, describe those. And then in the discussion, what you can do is 2 different options. What authors do is, in some situations, you can write a brief discussion for each of the experiments after their respective result sections. That's one option. And then you write a broader discussion at the end of the last mini discussion section for the third. And now you say, like, basically overall discussion that synthesizes and integrates and talks about and discusses what the broader findings were, their implications, and what they mean. So that's kind of a structural way to approach it. Is that close to answering your question, or is there a way I can do it better?
That definitely puts it together. Now, for experiment 3, is that something that you want us to come up with on our own?
Yeah, so you should definitely be coming up with your own hypotheses for experiment 3. Note that I gave a lot of suggestions of ones that you can use on some of the slides that I provided in the FACE ERP one. So hopefully you guys had a chance to visit that and look at some of those PowerPoints. I think I actually put it as a PDF or something, but we talked about them last class as well. So I had a lot of suggestions for hypotheses there in that one. And what we talked about last class is a suggestion for experiment 3. What I'd ideally like to see is an effort to do an oscillation analysis, which could be an oscillation analysis of exactly the same time points and conditions of what you reported in the European domain about. Right? The hypothesis, of course, in that case would be a comparison to see is there more information available about potential differences within the spectral domain than there is in the averaged ERP domain. Look at the exact same thing with a different lens. Is there something different? Do they differ, I should say? That's a hypothesis that you can test.
You can do that for experiment.
Oh yeah. Or you could ask something else. You could look for the oscillation analysis of a totally different hypothesis of things of contrasts and time frames and electrode sites that you hadn't looked at before. You can do it looking at aspects of clinical patient impairments that you have access to. A lot of stuff we talked about last class of different options for where you can direct those things. But what I would really like to see is obviously sort of a bridge between the 3 experiments. I want to give you guys latitude of your own autonomy and independence to do the hypotheses and the questions and analyses that you want to do. But I also want to provide guidance and suggestions along those lines. So by all means, do what you want in that capacity. But my suggestion is experiment 1, do as we did for lab report 1. Experiment 2, do something with the face memory ERPs. Experiment 3, do some type of oscillation analysis of something, just to try it out, see if it works. You don't have to follow that exactly, but it would be one suggestion. Does that make sense? Does that sound good? That way, it also gives you variety. So the reason I'm saying this isn't to like overload a bunch of work, changing gears and doing different things. I don't want you guys getting bored working with the same data over and over again. It's like, all right, I'm gonna do this thing. I want to be able to give you guys variety and experience working with different types of data and doing different things, because I'm hoping that'll keep you interested and active and vibrant. You know what I mean? But by all means, a lot of latitude and autonomy for you guys to direct that as you see fit. So did most of you guys have a chance to finish the lab report? Send over? Okay, cool. So, second part to your question, what are we expecting for experiment 3? That was the big sort of overview, and I would refer you again also to the video from class last week where we talked more in depth also about the third lab report expectations, which is very similar. Yeah.
I don't think
There's no sound on that one? No way. Oh man, that's terrible. Really? Oh, I hate when that happens. Sometimes, huh? Who knows how to read lips?
I tried.
You tried. I'm sorry. I don't know this stuff. I'm not a professional tech person for AV or whatever, but I tried. Dang, there's a lot of good stuff in that class too.
As the one school stuff, I was like,
Well, that does most certainly stink. I'll see what I can do. Let me see if I can dig up other aspects of it. Maybe I can salvage it. Okay, so then anybody have objections or suggestions for any ways that you would like to change that last lab report, like parameter? Yeah.
can you possibly give us a day to work on it in class so we can, if you have any questions about the lab report to ask you right there?
Sure. Well, yeah. So that's what I'm going to try to do for, the next couple weeks. We'll talk about some stuff today, but once I stop yapping, I'm just like last week, I cut you guys loose for an hour or two to just do whatever you need to do. That's the goal in every class now, is to give you some of those opportunities, but I'm not going to cut out a whole day to do that either, because there's stuff that we need to review. The last day in class, I think, is the 29th. That'll be a class like that. That'll just be an open class to finish what you need to finish, because there's nothing I can really teach you at that point to get integrated into that. So, that'll definitely be the last class.
And then also, when do you want us to turn in the screencast?
Screencast. How about by the weekend after that due date for the last lab report? That way you have a little bit of time afterwards, and it doesn't suck that you have everything due on the same day. Give you guys a little bit of time after that. So I think that we have class Friday, so the 29th, 30th, 31. Does that sound good? Or is there? I don't know if there's a 31st in April, but if not, whatever that month is. We can even make it Monday if you want after that weekend. So by Monday. Does that sound reasonable? Easy. So the other thing I was going to suggest to you is this for the third lab report. And this is sort of how research works sometimes. Completely unexpectedly, you have something come up that you've been working on this project now for 3 months. You've been busting your butt on your own. You've really been championing your work. You've come up with your hypotheses. Now you're stuck. There's a roadblock, and there's something about the data or the interpretation of the topic that you don't know how to fix, you don't know how to cross that bridge to resolve it. What do you do?
Outside opinions?
Okay, so you can ask for an outside opinion. How would that work?
Find somebody in the field who may be familiar with that and bounce ideas off.
Okay, so you bounce ideas off somebody in the field. Some basically, you might say that another way, and that you collaborate with another colleague or expert. In fact, that's actually how we got this paper from this morning published. Is it was a project that I actually had no role in designing. Didn't even know it was designed. Didn't know it was collected as data. But and same for the face memory ERP study. Dr. Bartlett, Dean Bartlett, he collected that data. She's probably almost 10 years ago, or I even knew. And then what happens is you run up against a roadblock, and he's like, "Well, I'm a cognitive researcher. I don't know how to do these ERPs and how to fix this paper to get it publishable or to work with the data in this capacity to bring home a conclusion." And so you reach out, just like Who Wants to Be a Millionaire, and you phone a friend, right? And so you form these collaborations. And so what ends up happening is you get brought onto these papers, sometimes without, and you just given a bunch of stuff, and you're like, how do I make sense of this? And you have to sort it through. Or other times you ask for a friend to help sort it through, and you bring different respective expertises together. And so what happens is you end up with collaborations, sometimes with people you don't even necessarily agree with on things. Because, I mean, this happens a lot in like molecular biology. I was reading a paper about stem cells where, you know, they had this idea about stem cells regenerating, and they had X, Y, and Z experiment done, but in order to get published, they needed to do this other thing. They didn't really know how to create this other transgenic mouse to create this really perfect experiment to test out their idea. So they had to call up some other colleague in Japan at the Riken Institute. They might not even like that guy that much, but you get along together. We're professionals, right? Like, you don't have to be friends. You just have to, you know, like everybody here has worked a job, right? Like, you work together. So for the third lab report, the idea will be to find two colleagues, and now you write a paper together. So now you have hands on deck. So find two of your closest. Doesn't have to be friends. Sometimes it's worse if they're friends. But find, if you want. Look, if you want to go solo, knock yourself out. Go solo. But my suggestion is actually to use the opportunity to establish some collaboration skills and some teamwork development as well. Because, you know, we think of science as like kooky old crazy scientists poking away in their laboratory. They're, you know, but at the end of the day, it's actually a lot of teamwork. And it's very, very difficult to find scientific efforts that are not based in teamwork in one capacity or another. And just like most aspects of teamwork in any capacity, right, how that team works together can make or break the project. Right? It can make it a great project, it can make it a crappy project, it can make it a great experience, or it can make it actually miserable too. So use it as an opportunity to work together and build and practice some of those skill sets. So you can integrate your individual lab reports of experiment 1 and 2, bring them together to a single paper together, take the best parts of everybody's, weave it together. Don't get hurt feelings if some of your favorite sentences that you wrote have to maybe not be included in the project, because this is part of collaboration, is like dealing with these interpersonal things of, we get married to exactly what we wrote because we really liked it, we thought it was awesome, and then someone's like, yeah, it just doesn't work real well with the direction that the group's project needs to be in. And we have to divorce ourselves from some of our favorite sentences or paragraphs at times. And it's a process. Like, so don't take things personal. You have to integrate, you know, the strengths and weaknesses from each individual thing. And so we can do that if you want. If you, like I said, if you want to go solo, by all means, do the third version solo. But if you want to work together with people, work together. And particularly that you can work on that last third component to it too, and integrate those different things. And this is actually a really, really good exercise, because this is actually like how it tends to happen in some things. So I had a paper in 2011 it's about theta pre-stimulus, and it's experimental subjects, 30 to 53 in your data sets was those, or whatever, 30s to the 50s, those subject numbers was the people in that paper. And me and two of those authors on it designed the study. I ran the whole study by myself. I analyzed it all myself in one way. And then another of those authors joined the lab and decided to analyze it not in ERPs but for oscillations in a totally different way. At the time, I didn't even know what oscillations were. He had to teach them to me. And it turned out that he found really, really cool stuff in it that was the very heart and the backbone of what we ended up publishing. And then we brought another author on. His supervisor was right. So now it started off as basically my dissertation work by myself and my two supervisors who were kind of involved in designing it. Now we've got two other cooks in the kitchen, all great guys, great people, great scientists. But now what I thought I was going to be writing up by myself, you've now got 5 people in everybody's views, and everybody looks at things a little differently, right? So we all kind of have our own lens. And you have to write a lab report about it. And you have to work through some of those things. So these are actually like real life things that are really good to practice on. Because the ability to write together with people is essential. And is a very good skill to practice as you're learning even writing together with Ariel for drafts and things like that. Ariel, do you have any teamwork experiences in science?
About writing or about
Anything. It's pretty, yeah, like it's pretty much the essence of it, right? Like,
you have to be able to get along with people.
like, have you ever worked on a paper or project where you just did everything by yourself?
Yes, and it's terrible.
So, does that sound good for you guys? Yeah? How many of you guys think you might want to do the joint project? A couple of you guys? Okay. Cool.
So you have to specify like who did what part.
Yeah, you do.
So where do you do that?
You do that at the bottom of the manuscript.
So do we put like the numbers and stuff?
Yeah. In fact, that should be in your APA manual. Yeah, you know. All right.
So
See? Yeah, why did you save her? That's what she wants to know. Yeah, so now I know who's reading the book and who's not. But yeah, good job, Tom. But yeah, I mean, that stuff is in there. And those are always the easiest parts to do, right? It's just like a sentence or two, you zip it out, this person, and you use like your little initials, RJA designed the study, and PQZ, analyze it, and then everybody wrote it together. I mean, yeah, those are easy but important details that you, like, ethically, we have obligations to make sure we're reporting properly. And actually, to be honest, different journals have different rules for that, which complicates your life when you start writing, because every journal formats just a little bit differently, sometimes away from APA style. They never tell you that in your research methods class, but it's true. And some journals actually require you to put those disclaimers in there. Others don't really give a crap. So it's for good practice, and for the class we'll do that. So that's kind of what I wanted to introduce. I want to cut you guys loose to start working on your analyses. Start trying out, see where the error messages are. If you start looking at these oscillation analyses, look for the EFFT, look for the TFFT. I provided some of those scripts, I think both in the box folder as well as the e-learning thing last week for group batch processing of that. So, we've got a lot of time in class, so use the opportunity that we have to try that stuff out, because we have it's due April 29th, right? We really only have about 2 to 3 weeks to really dial in your data analysis. And you're going to have to start doing it together with other people, right? And talk and have meetings and collaborate and decide, well, what are the analyses what are the hypotheses that we think are the most important to test or interesting to assess, right? And start working on how we're going to analyze this. Now, there might be error messages that you have to work through. And maybe, who knows, maybe it doesn't work and you have to go back to the drawing board and say, you know what, this whole oscillation thing, we can't get it to sort out. ERP lab is still in beta testing mode for oscillation stuff, or maybe we have to learn how EEG lab analysis does and we have to go watch their tutorials, or maybe we just can't get it and it turns out that there's more work that needs to be done, so we'll take our third experiment and look into the face memory study, right? There's really not a lot of time, 2 or 3 weeks to sort this out, and then because so you got about 2 weeks, because a later 2 weeks we'll be writing up, revising, writing up, revising, writing up, revising. So fair warning, it might seem like we've got time here, but it's going to go pretty quick. So basically what I want to do for the rest of the class is cut you guys loose to pursue those things if you want, and then simultaneously, for those of you guys who expressed an interest in talking about measures of non-conscious memory, which of course you can absolutely include in your analyses if you're so inclined. I know you have interest in including those types of things. I was going to explain some of the procedures that we've developed more recently and how that works. So a little bit of dual mode. So for those of you guys who don't give much of a hoot about the implicit memory procedure, you can start establishing your collaborative relationships. Start working on those projects and the data analysis. And for those of you guys who are interested, we can talk a little bit about implicit memory in a little bit more detail. How does that sound? Does that sound like a pretty good plan? Okay, cool. Guess we'll take 5 or 10 minutes, well, 5 minutes, refresh, get some coffee or food, and we will reconvene about implicit memory. Awesome.